Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're talking about collecting like terms, our first video. As always, let's link to what we already know. When we did SIRS and someone asked us to simplify or collect the following, root 2, add 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 root 2, we just said, do you remember? Well, that's the same as 6 lots of root 2. Which we actually just dropped the multiply sign and said that's just 6 root 2, like this, 6 root 2. And from now on, remember, from previous videos I said we should really use the identical sign because they're just different ways of writing the same thing. So, in this video we're going to deal with things like x add x add x add x add x add x. How would we write that? Yeah, it's exactly the same, guys. We would say it's identical to 6 lots of x. Okay, we wouldn't write 6 multiplied by x because we don't do that in our algebra. Alright, so that's the type of thing we're going to be doing here. This is called collecting up like terms. X is like another x, we're just collecting them up, mopping them up and telling us how many we've got. And that's basically what this video is. Just before we get going, let's just learn a little bit of terminology. Suppose you were considering the following: 2x add 5y add 7x. That is called an expression. Okay, so I'm just going to show you what each thing are. 2x add 5y add 7x is what's called an expression. Remember, it might have letters for algebra, it might have numbers, and it might have operations like add, subtract, multiply and divide. So what are our operations in this case? In this case it was add, but they could be add, subtract, multiply or divide. What's our variables? Let me highlight them and see if you know. The variables are the letters we use. They can vary in value. They're the unknowns. So our variables here are our letters. In this case, our x and our y. What do you think the coefficients are? Well, let me highlight them and then you tell me. That's a coefficient, that's a coefficient, and that's a coefficient. The coefficients are the numbers in front of the variables. So they are the numbers in front of the variables. And that's important to know. Okay, so we've covered that. Now what do you think a term is? Again, I'm going to highlight a term for you. That's a term. That's a different term. And that's a different term again. So a term is just a part of the expression. It's the things that you're adding together or multiplying or subtracting or dividing. So in this case our terms are 2x, 5y and 7x. We've got 3 terms. Now here's where this is what this video is basically all about. What do you think a like term is? A like term is obviously a term. Which terms here are like? Well, 2x and 7x are what's called like terms because they're involving x's. Alright? And 5y is an unlike term to x terms because it doesn't have x's in it. So we would say, for example, a like term here is 2x and 7x. They can be collected up and we could actually say we've got 9x if you think about it. Whereas 5y can't be collected up with anything. It's what's called an unlike term. It's unlike to the x's anyway. And they're the basic things we need to understand when doing this topic. So let's get ahead and just do some questions. We are going to be dealing with things like this, collecting the terms that are like, simplifying them, and writing down an answer. Alright, let's have a go. Collect the like terms here. Now, I want to show you how to do this. I want you to always highlight your like terms. We've got an A, and I also, after you've highlighted the first one, I want you to highlight the next term and the operation in front of it. We've got an A, and we are adding it to another A, and this is identical to 2 lots of A. Nice and easy. Next one with B, let's use a different colour. We've got a B, we're going to add a B, remember to highlight the plus as well, and we're going to add another B. What have we got? That's right, 3 B's. And it's basically this throughout the video, but just getting slightly more complicated. So for each example, please feel free to pause the video and try. For example here. Try that one before I show you. Okay, highlighting like terms. We've got 2p. We are going to add a p which we can think of as 1p. It's helpful to do that. And we are going to add another 4p's. What have we got? Well, we've got 2p, add 1p is 3p, add 4p is equal to 7p's, or identical to 7p's. Next one, do have a go yourself first. We have 5q. We are going to add a q, which we might put a 1 there just so we don't make a mistake. And after that, we are going to subtract this time. So remember to highlight the operation as well. 2q's. What have we got? Well, it's identical to 5q, add 1q is 6q, take away 2q's is going to equal 4q's, and we're done. Next one, pause the video and have a go yourself. So here, what have we got? We've got ourselves 2x's, and we are subtracting 7x's. Now think back to our number work. What was 2 subtract 7? Well, it was -5, wasn't it, by the symmetry of subtraction. So 2x's subtract 7x's must be -5x's by the symmetry of subtraction. And the one below, we're collecting z's here, so let's go. We've got -5z and we're taking off another z. We've got -5z. If I said to you what's -5, take away 1, using your negative number work, you would know that's -6. So here this must be the same thing, therefore, as -6z. Simple as that. Okay, let's keep going. Please pause the video and try this one yourself. So, highlighting like terms, what have we got? We've got ourselves 2x. We're going to add 7x, and they're like. Let's go for the next lot of like terms. Let's go, now think of that as positive 5y, and we're going to add another y, which I might put a 1 in there just to remind me it's 1y. And let's go, we've got a positive z, might even put a 1 in there for 1z. And what are we going to do? We are going to add 3z's. Now use the identical sign. This is identical to 2x add 7x is 9x. Positive 5y add another 1y is positive 6y, so we write plus 6y. Positive 1z add another 3z is going to be positive 4z. And we leave these unlike terms like that. We have collected as far as we can. Now do know I do these in alphabetical order. I write this, how many x's I've got, and then how many y's, then how many z's. That's how mathematicians tend to do that. So we're going to stick with that convention. Right, have a go at this one. Right, so as always, highlighting our like terms, we've got positive 2x's, we're taking away a 7x. We've got ourselves positive 5y, we're going to add a single 1y, which we might write in like that. And we've got ourselves a positive z, and we're going to subtract 3z. So let's see what we've got. Write the identical sign. 2x subtract 7x by the symmetry of subtraction is negative 5x. 5y add a single y is positive 6y, so we write plus 6y. And positive z subtract 3z is negative 2z, again by the symmetry of subtraction. And I've written them in alphabetical order, and we're pretty much done. A tiny little note for you, just because you're going to see this in textbooks and maybe in exams. Sometimes mathematicians don't like writing the negative one first. So if there's some negatives and a positive, they might write the positive first, in alphabetical order, all the positives, and then they would write all the negatives in alphabetical order after that, like this. So in a textbook, you might have been asked to simplify or collect like terms for this. They simplify and collect like term mean the same thing. The answer in the back of the book might look like this, but it's exactly the same as that. So just to point that out to you. And last one for you, pause and do have a go. Okay, we've got negative 2c, we're going to subtract another c. We've got positive 5a, and we're going to add a single a, which I'll write in there 1. And we've got ourselves positive 1b, and we're going to take away 3b's. Okay? So I'm going to do them in alphabetical order. I'm going to deal with the a's first. Positive 5a add 1a is going to be 6a, which I'm going to write here with my identical to sign. Then I'm going to deal with the b's. Positive b, take away 3b's is negative 2b by the symmetry of subtraction. And lastly, negative 2c, subtract another c is going to be negative 3c. And we're done. So that's it for this video. Thanks for watching.